Breaking news. The 2025 Nobel Prize in Chemistry has just been awarded to three pioneering chemists: Susumu Kitagawa from Kyoto University in Japan, Richard Robson from the University of Melbourne in Australia, and Omar M. Yaghi from the University of California, Berkeley in the USA. These brilliant minds are being recognized for their groundbreaking work in developing metal organic frameworks, or MOFs, which are superporous materials that could revolutionize everything from clean energy to medicine. If you caught our previous video where we predicted the Nobel winners, you'll remember we called it for Metal Organic Frameworks and Omar M. Yaghi. Let's break this down and talk about what these scientists have achieved. Metal organic frameworks are like molecular sponges. They're crystalline structures made by linking metal ions with organic molecules, creating tiny pores that can trap gases, separate chemicals, or even store hydrogen for fuel cells. The beauty of MOFs is their tunability. You can design them for specific tasks, making them incredibly versatile. Starting with Susumu Kitagawa. He's a professor at Kyoto University and one of the early pioneers in this field. Back in the 1990s, Kitagawa was experimenting with coordination polymers, which laid the foundation for flexible, porous materials that can breathe, expanding and contracting to absorb or release molecules. His work showed that these frameworks aren't rigid. They can adapt dynamically, opening up applications in gas storage and separation. Imagine capturing carbon dioxide from the air to fight climate change. That's the kind of real-world impact we're talking about. Kitagawa's research has inspired countless studies, and he's published hundreds of papers that have shaped modern materials science. Next up, Richard Robson from the University of Melbourne. Robson is often credited with kickstarting the conceptual framework for these materials in the late 1980s and early 1990s. He proposed using simple building blocks, metal nodes connected by organic linkers, to create extended networks with predictable structures. His visionary papers essentially provided the blueprint for designing MOFs from the ground up. Without Robson's theoretical insights, the field might not have exploded the way it did. At 84 years old, this award is a well-deserved capstone to a career that's influenced generations of chemists. And then there's Omar M. Yaghi, the one we predicted would take home the prize. Yaghi, based at UC Berkeley, took these ideas to the next level with reticular synthesis, a methodical way to build MOFs and covalent organic frameworks, or COFs, by stitching molecules together like Legos. His team has created over 500 different MOFs, some of which hold records for surface area. 1 gram can have the surface area of a football field. Yaghi's innovations have huge implications for water harvesting from air in arid regions, hydrogen storage for clean vehicles, and even drug delivery systems. He's not just a theorist. His work is being commercialized right now, bridging the gap between lab and life. Together, these three have transformed chemistry by turning abstract ideas into practical materials that address global challenges like energy storage, environmental cleanup, and sustainable manufacturing. The Nobel Committee highlighted how their discoveries have opened up a new world of porous materials with unprecedented properties. It's a testament to international collaboration spanning Japan, Australia, and the US, and shows how foundational research can lead to game-changing technologies. This prize comes with about 11 million Swedish kronor, split among the winners, but the real value is in the recognition of their legacy. If you're into chemistry or materials science, dive into their papers. They're fascinating. Drop your thoughts in the comments below. And don't forget to like and subscribe for more Nobel breakdowns and predictions. We nailed this one. Who knows what we'll forecast next? Thanks for watching, and I'll see you in the next video.